Hello and welcome to this class. Let's look at the past questions in the study of general dynamics. So let's take like 3 to 4 past questions under this topic to understand the concept in depthly. So let's look at example 1, 2, and 3 under rotational dynamics. Example 1 says, if a wheel, 1.2 meter in diameter rotates at 1 revolution per second, calculate the velocity of the wheel. Option A, B, C, and D will be shown in the screen, right? So I'll show you the options in the screen. So the question says, if a wheel, 1.2 meter in diameter. So first there, I'm given diameter in the question. So solution there. So I'm given diameter has been equal to 1.2 meters. Next task there, it says rotate at 1 revolution per second. Please, when it comes to revolution per second there, if I have revolution per seconds, this man here signifies what? Angular what? Velocity. This man here signifies angular velocity. So I'm given omega, that's angular velocity, omega. So angular velocity, that's your omega, to be equal to, the value is 1 revolution. So 1 revolution per second. So I have this place. Next task, it says calculate the velocity of the wheel. So find V. So find V, calculate velocity. So velocity, that's V of the wheel, is unknown. All right. Now look up, please. Some of you might be confused that why is it that I said that revolution per second is angular velocity? Why is it so? Here's the concept. What do we know? One revolution is equal to what there? 2 pi rad. That's it. So I'm just literally saying that this one here signifies 2 pi rad, and this seconds per seconds. So what we are familiar with was rad per seconds. So rad per seconds, and so rad per second is the same thing as what? Saying revolution per seconds. So revolution signifies 2 pi rad, then per second is this. So I'm saying that these two are the same thing, please. They are the same thing, please. So first, I will have to convert my angular velocity. So of course, my angular velocity, that's omega, was given in form of 1 revolution. So I have 1 revolution per second. What do we know? We know that 1 revolution is what? 2 pi rad. So I have that 1 revolution, as we established earlier, was equal to what there? 2 pi rad. Now input this man here, the value, or perhaps the exact value of angular velocity, that's omega, will be equal to what? 1 revolution is what? 2 pi rad. So I have 2 pi rad per seconds. So this is the exact value of angular velocity. So I'm asked to find V, and V is said to be the linear velocity. So when I gave you a relationship, please, I said recall that we said relationship between angular velocity omega is equal to what there? Linear velocity, that's V all over R. I gave you this formula when we discussed about angular velocity. I gave you this. Now I'm trying to look for V. I'm asking for V. So make V subject. So I'll have to multiply. So I'm saying that V now should be equal to angular velocity times R. So times R. I have this place. Input value. First things first, I'm not given R, but I'm given diameter. Of course, from here. So diameter D was equal to 1.2 meters. I said you can get radius from diameter. How? Recall from the mathematical expression that says that radius is equal to what? Diameter over 2. I gave you this stuff. Let's get R. For me, R should be equal to, diameter is 1.2. So I have 1.2 divided by this 2. If I divide this one here, R should be equal to, if I punch 1.2 divided by 2, this gives about 0.6. So I have 0.6. So 0.6, of course, in meters. So my R now is now 0.6 meters. So from I'm given diameter, I have now gotten radius from diameter. So here's the concept now. I'm asked to find V. I need two things: angle velocity and radius. This one here, this is a value here. This R here, this is a value here. So combine with them, all I have here. So I'm saying this, please. Finally, I will have that V will be equal to angular velocity is of course 2 pi rad per 2 pi rad. I have 2 pi. I will ignore the rad per seconds away. Then times multiplied by R. What's R? 0.6. So I have 0.6. Of course, V is equal to V should be equal to I'll multiply. We know that pi is 180, right? So pi, we said, is 180, right, in this topic. So I'm saying that 2 into 180 times 0.6. V should be equal to, if I punch my calculator, there, so 2 times 180 times 0.6. So that's around 216. 216. So let's do the pi here as 22/7. So let's 22/7 is given in the question as 22/7. So let's 22/7. 22/7. We are asked to use. We are asked to take pi. Take pi as 22/7. It's stated in the question, please. So from here, multiply this again. If I multiply this, that's 2 times 22 divided by 7 times 0.6. This gives about 3.76. This gives 3.76. Please, velocity is measured in meter per second. So I have meters per second. Some of you will say, because I'm having V, so that's V equal to this one here, omega is rad per second. So that's a rad per second times radius is R in meters. I'm not asking what's the essence for this answer. Some people will not say this is rad meter per second. No, please. This is not. I'm not dealing with angular velocity. This is just a linear velocity, and it's measured in what? Meter per second. Don't put X sign while solving them. Just know the X sign for each parameter, and then that's all, please. So that I get the velocity for this particular question. Let's take example 2 and proceed. So let's take example 2. Example 2. So let's take example 2, please. Example 2 says, if an object whose mass is 3 kg moves in a circular path of radius 0.7 meters, records a speed at 2 meters per second, what is the result of the angular velocity? That's all. So now listen, please. We said first things first, when you read out question in science, your first task there is to list out the given parameters, please. So for instance, what I'm given here, it says if an object whose mass is 3 kg, so mass of an object, mass in bracket m is what? 3 kilogram. All right, proceeding please. Moves in a circular path of radius, so I'm giving radius, that's r, has been equal to 0.7 meters. Records a speed, so speed is the velocity, that's your velocity, that's v, that's your speed, that's 2 meter per second, 2 meter per second. All right. It says what is the result of the angular velocity? So find angular, that's your omega. So angular velocity is simply omega, is unknown. All right, let's get omega. First, what do we know? That's the concept. What do you know? I'm asked to find angular velocity. We know that, or perhaps we established earlier, so recall that we said angular velocity, that's omega, is equal to, there are two ways. Either I use v over r, or I choose to use this one here, theta all over t. Right? So that I give these two formulas under angular velocity. Now here's the concept. I'm asked to find w, perhaps, please, omega, not w, omega. I can use two formulas, this or this. Looking at these parameters here, which one best suits to solve it? It's easy as I'm given mass, I'm given radius and v. Please look at this part here. Angle theta is not given here at all. Time is not even here. So it means that I'm not going with what? This formula here. Rather, I'm going with this one here. Why? Because velocity is given, radius r is given. Now here's the concept. In this case here, the mass given has nothing to do. So the mass there is just like a confusion. So it has nothing to do here. So let's get the omega. Let's get omega from here. Let's get omega. So said from here, using this one here, omega. So omega is equal to, we have v over r. So that's v all over r. What's v? You said v is 2 meters. That's 2. V is 2 meters all over. What's r? R is 0.7. That's half 0.7. Divide 2 by 0.7. Omega, which is angular velocity, should be equal to, if I punch my calculator, 2 divided by 0.7, I have about 2.85. All right, 2.85. I have 2.85. Please, what is my unit? What's the unit here? We said this man here is angular velocity. That's what the theta over t. Theta is angular displacement. That's rad. T is seconds. So don't forget that angular velocity is what? Rad per seconds. So this man is measured in rad per second. So rad per seconds. Why? Angular velocity. All right, so I have this second question done. Let's take one last question. Let's take one last example. Let's take one last question, final question under the study of rotational dynamics and see how it works. It says an object moves in a circular path of radius 0.5 meters what with a speed of 1 meter per second. What is its angular velocity? So let's get this done, please. First, an object moves in a circular path of radius So I'm given radius as being equal to 0.5 meters. Let's start with a speed of 1 meter per second. So speed, that's V. V is equal to 1 meter per second. What is its angular velocity? That's omega. So find angular velocity. So angular velocity is unknown. That's omega. Omega is unknown. Please observe my omega. I didn't write W. This is not W. No, it's kind of curve. See, observe. It's a kind of curve concept. It's not just W. No, it's a kind of curve concept, please. So I'm given that angular velocity. I must to find angular velocity. What do we know? Angular velocity, that's omega, is equal to what there? V over R, as clear given here. What's V? That's 0.5. What's R? That's 1. So omega is equal to what there? 0.5 rad per second. This is how you solve this particular question. Sorry, please. We said V is 1. Please, V is 1. So V is 1. So V is 1. R is 0.5. Please, sorry. 0.5. If I divide this stuff here, if I divide this stuff, 1 over 0.5 there, what should I get? 1 divided by 0.5, that's 2. So I have 2. So that becomes 2 rad per second. Alright, this is how you solve this particular question. If you found this class helpful, do what to like, hit the subscription button, follow for more videos of this nature. Also, you can join my channel membership, the WAEC/JAM membership, which is of course cheap. You can join the membership so you can have access to exclusive videos of this nature. Also, I just launched a website called I just launched my website, which is www.ganiyubakar.com. My website there, you have close to 4 to 5 courses you can get. So I have the physics courses, I have the organic chemistry courses, I have the JAM and WAEC courses, and etc. Go there and purchase the course of yours. Also do well to like this video, share to your friends and classmates, and leave a comment if you like this video. Also tell us what video you want us to upload in our next class. See you guys in our next video.